Yeah, let's go ahead and get started. We're going to talk about transport category aircraft, kind of their design and types and what it is, what we're going to be studying the systems of, what we're going to be talking about as we get into the systems some more. So first, let's figure out what a transport category aircraft is. So transport category aircraft are defined by exclusion. If I say they're defined by exclusion, what does that mean? What do you think I'm talking about there? What's the, yeah. What they don't count as, which is exactly right. So in the Code of Federal Regulations, in 14 CFR 23, we have airworthiness standards for normal category aircraft. And I've got the link there. If you go to CFR Part 23, this is the page it'll bring up. And as you go into 23, it's 23 2005. Went too far. 23 2005 here. Let me. We have certification of normal category airplanes. So certification in the normal category is airplanes with a passenger seating configuration of 19 or less than or equal to 19, or with a maximum takeoff weight of 19,000 pounds or less. Okay. So that's our normal category airplanes, which are the kind of the smaller airplanes that you did in your basic systems class. We're looking at transport aircraft, which are covered in CFR 14 CFR Part 25. And so if you go into 14 CFR Part 25, it doesn't actually say what a transport category aircraft is. Essentially, it is anything not covered under Part 23. And so these are, so it's got some special air regulations because you got some oddballs in there. A lot of them deal with like the DC-3 was kind of the first transport category aircraft, and it's where they had to kind of create, the new rules had to be created to deal with things like the DC-3 and bigger. You know, DC-3, McDonnell Douglas DC-3 twin engine piston airplane. But when we get into this, what essentially it has is transport category airplane. So it doesn't, nowhere does it actually say what it is. It's just assumed that if it's not specifically covered, if it's not less than 19 passengers or less, and if it's not 19,000 pounds or less, then it falls under this. And what it is the transport category aircraft regulations are more stringent. They have additional requirements. My slideshow got ahead here. Than the non-transport category. Bring that back up. And going through Part 25, it has all kinds of information about what they have to have. So it has things like weight limits. It talks about things like minimum weights, maximum weights. How are those calculated? What are they defined as? So, here like maximum weights correspond to airplane operating conditions that are on the ground. Okay, that's basically the airplane fully loaded, everything on it. How much can it weigh sitting on the ground? The minimum weights is with absolutely nothing in it. Lowest weight, design minimum weight, which complies with structural loading conditions. A lot of this stuff looks at like structural loading. You're dealing with big, heavy, big forces. And so they want to make sure that these aircraft are not just going to come apart in the air. The other part of it, things like CG limits, prop stuff, and then it gets into like pressurizations and vapor pressures. Just, you can see the section goes on and on and on and on and on. So if you decide you want to go out there and create the next transport aircraft, this is the minimum regulations and the minimum requirements that you're going to have to follow. In the news, I think there's a new company that's trying to do a startup supersonic aircraft. Anyone seen that? What's that? Boom Aviation. They've never built an airplane before. They got to figure out all this stuff and how it applies. There's a lot of back and forth on whether they're going to be able to do what they say they're going to do or not. So, yeah, I mean, look at that. That's simple, right? For load limiting and that. Okay. But for our purposes, what's important here is we know that this is basically more than 19 passengers or more than 19,000 pounds. And so where that applies is oftentimes, so pretty much anything you fly, anything you're going to buy a ticket on is going to fall into this transport category, into the transport aircraft category. Some corporate aircraft are going to be on the fence, but the big key is even though you might have a corporate aircraft that only holds 6 or 7 or 8 passengers, but a lot of them are easily over that 19,000 pounds max takeoff weight. And that's what it's referring to as max takeoff weight. So max takeoff weight is not quite maximum weight. You can actually have, there's a max ramp weight, which is the airplane can actually carry a little bit of extra weight, so it has fuel to burn to get to the end of the runway, but by the time it gets to the runway, it has to be down to the max takeoff weight. And so max takeoff weight less than or equal to 19,000 pounds. When you start getting into even like corporate jets, they very, very quickly get over that 19,000 pound limit, even if they only carry 6 or 7 or 8 passengers instead of the 19. Yeah. No, that's passenger. However, you got to know what's the flight crew certified as. So some aircraft are single operator, some are 2 crew, right? So like a straight wing Cessna Citation can be flown by a single person. So the right seat is technically a passenger, but then none of those are going to be over 19 passengers anyways. You know, anything that carries 19 passengers is going to have a minimum of 2 crew. And some have 3, although less and less. There aren't too many 3 crew aircraft out there anymore. And we'll look at that. But this is strictly passengers. I honestly don't know if cabin crew is, I don't think cabin crew is part of that. Cabin crew is like flight attendants. I don't think they're part of that either, but I'd have to double check on that. I'm not 100% sure. So what are we looking at? So these come in a few different, those are the officially defined categories, right? The regulations define these transport aircraft and general aircraft. When we look at just the transport side of things, now we can talk about kind of some different breakdowns there, but these aren't official breakdowns. There aren't regulations that say, well, this is a large transport and this is a medium transport and this is a small or a regional, but there's kind of some rules of thumb. So larger transport aircraft are typically anything that has 100 or more passengers. Okay, start getting into aircraft with 100 or more passengers. These are highly complex. They have a lot of different systems, a lot of redundancies, backups, redundancies, and interdependent systems. And almost all of them today have multiple turbofan engines. There are a few turboprops out there, although they're not considered typically large. They're more in the medium to smaller regional category. Even these large transport aircraft can be broken up oftentimes into light, heavy, or super heavy. And it roughly deals with weight, but there's something else that tends to break down an airplane between light and heavy, or what you'll hear heavy. So how many of you have listened in, has anyone ever listened in on air traffic control at a busy airport? Have you ever heard them referred to an airplane as heavy? What kind of airplanes would be heavy? Usually get. What's that? 777's considered a heavy. The 747's a heavy. A320 is not a heavy. A380 is definitely a heavy. What do we got? What's kind of the one versus the other? Huh? What do you think? Where does that heavy moniker come from? Yeah. It's not the number of engines, because like a 777's only got 2 engines on it. So the what? The number of seats or the number of aisles? Kind of. We'll talk about another thing called wide versus narrow, and that's where the aisles come in. But most of the time, a wide body is a heavy, a narrow body is a light. What's the difference? What's the big difference that air traffic control uses it because part of it depends on how far they space apart airplanes on takeoff. If you're following a heavy, if you're going to take off in a small airplane, you're following a heavy aircraft, they're going to make you wait longer before you can take off. What's the concern there? Yeah. I mean, just bigger aircraft tend to need more distance. This is more like how long they wait for the next airplane to take off. The wake turbulence, the tip vortices off the wingtips and the tail. So heavy aircraft tend to have a lot of wake turbulence. And the way these are is we'll get into a wide body, or so a narrow body is typically a single aisle aircraft. A wide body is typically a two aisle aircraft. And most of your wide bodies are heavy airplanes. They have higher wake turbulence, higher, more turbulence behind them. There is one narrow body aircraft that's classified as a heavy, however. Anyone know that? So the one single aisle airplane that gets classified as a heavy is the 757. For some reason, the design of the 757 produces larger wake vortices, bigger turbulence than a normal single aisle airplane does. The newer ones with winglets on them, it helps it somewhat, but they still have to space planes out. So super heavy's getting into like your 747s, A380s, the double-decker type stuff. So wake turbulence and vortices is the big thing there that determines whether a plane's considered heavy or not heavy in the large transport category. Smaller transport category aircraft, this includes things like regional jets, which is typically somewhere around 40 to 100 passengers. That's that niche below that. Regional turboprop aircraft, so anything with more than 19 or even 19, the Beech 1900 is a 19-passenger airplane. That's considered a regional turboprop. So 19 to 50 passengers, roughly. And then medium and large corporate aircraft. This is all of your Falcons, your Challengers, your larger Cessna Citations, your Hawkers, what other ones am I missing here? What's that? The Q400-8, that's a regional turboprop. That's that 50-passenger turboprop, Q400-8. Okay. So medium and large corporate aircraft, again, especially the medium corporate aircraft, most of them are not going to have the 19 passengers, but they're going to be over the 19,000 pounds. These have similar, or most of the time, the same systems as large transport aircraft. They might be pared down a little bit, but they're going to have all those same, they're still built under that Part 25 requirement. They still have a lot of the same requirements. Now, there are more stringent requirements for bigger airplanes that carry more people. You may have to have a little more redundancies. If you're flying over open water, over oceans, there's an additional set of regulations you have to follow because you don't have diversion airports as close. But they're going to have similar stuff. So that brings us into all of these, that Part 25, a lot of it pertains to, you saw like structure, how do you build it, loading, but it also pertains to systems and what systems have to be on board and how redundant they have to be and how reliable they have to be. So what are systems? What are some aircraft systems? What are systems we might find on bigger aircraft like this? If I were to say systems, what? Yeah. So we got hydraulic system, environmental control system, fuel system, fire protection and fire and overheat protection, ice and rain protection typically are grouped together. Okay. So here's my list, and it's by no means exhaustive. So APU, consider a system. APU is auxiliary power unit. This is the third jet engine on a twin engine airplane. There's actually usually a third little jet engine there that nobody knows about. Provides supplemental air and electrical power, auxiliary. Pneumatics, environmental control, anti-ice, de-ice, rain, electrical, fuel, hydraulic. You guys got a lot of these. But landing gear is also considered a system. Oxygen, fire detection, protection was brought up. Warning systems, communications, instruments, navigation, potable water and waste. People need to go poop and pee when they're in the air. People need drinks of water. Don't ever drink the coffee on an airplane, by the way. Potable water systems are nasty. They fail tests almost every time we send them out for bacterial contamination tests, even right after we sanitize them with bleach type solution. They still fail. So your coffee has fecal coliform in it. Yeah. Don't drink anything on the plane unless it comes out of a can or a bottle. Equipment cooling. We got to keep all those avionics computers cool. We got to keep hydraulic systems cool. You know, a lot of stuff builds up heat. Lighting. We need lighting, exterior lighting, interior lighting. We need lighting so people know where we are, which direction we're headed. We need to be able to see where we're going when we're on the ground and when we're landing on approach. Power plant systems, the engines themselves are considered a system. Emergency systems, interior and passenger fittings, seats, overhead bins, reading lights, you know, the entertainment systems. So there's more and more and more beyond this, but you know, all these things are considered systems. Now, some of these can be broken down into what are called subsystems, systems versus subsystems. So what would be examples of, if I said a subsystem, give me a system and what are its subsystems? Where do you, what's something you might think about? Environmental, so you got heating, cooling, what else might be part of environmental? Pressurization, right? It's kind of a subsystem of environmental. Any others? What else might have subsystems? Yeah. So the power plants, and we're talking about this more in power plant classes, you have the engine itself and then like the fuel system on there, the you know, that feeds fuel to the engine. What else? Where else might you have subsystems? You had a few. So the first one I do have is ECS, like Jensen mentioned. So the pack itself, the air cycle machine, heat exchangers, valve, ducts, water separator, right? That's what takes the hot bleed air and cools it. There's recirculation fans. We got fans and filters that move air around the cabin. Cabin temp sensors and control. We have to have something that feeds back into that environmental control to tell it, does the air need to come out hotter? Does it need to come out colder? Do we need more of it, less of it? Ice and rain. Things like heated leading edges. This could be leading edges of the wings or the leading edge of the engine inlets, what's called the lip skin. Heated probes. We want to keep our pitot-static probes and that kind of thing free of ice so that the instruments work properly. Windshields, we got to be able to see out of them. Heated windshields. Also could include, you know, ice and rain. Windshield can include things like windshield wipers or chemical rain repellent systems. We'll look at that. Fuel, engine fuel feed was brought up. But in addition to feeding the engines, we got to figure out a way to get fuel on the airplane. Sometimes we got to take fuel off the airplane for maintenance, that's defueling. Sometimes we need a transfer for some reason. We've got to fuel can play into weight and balance because it's in the wings. We got to be able to sometimes move fuel side to side. Or larger aircraft, there's a requirement that airplanes have to be able to get down to their maximum landing weight within, depending on the airplane, typically somewhere within 90 minutes or so. And so if they can't burn the fuel down fast enough, they have to be able to dump fuel. The 727 we have out on the ramp has a fuel dump system on it. If you push the breakers in, flip the right sets of valves, and turn on the right pumps, it will dump fuel onto the ground. We have those breakers collared for a reason. Okay? And you got to kind of know what you're doing to get it to happen, but it can, in theory, dump fuel all over the ground if you're not careful. So, level indication. The crew's going to want to know how much fuel they got left. Is there enough to make the trip? Will they make it back to land? So, the other thing we have is that we have all these systems are interdependent. And what do I mean by that? What is interdependency? Yeah. So a main system or a system feeds into another system. It doesn't necessarily have to be smaller, but it can be another system, right? Nothing works in a vacuum on the airplane. Systems run off one another. So anyone want to, what might run off of something else? What do we got? The what? A vacuum system. That's more of a small airplane thing, but it works. Some big airplanes have vacuum, not more. Vacuums on big airplanes are used more for toilets than they are for instruments. Anyone ever flown on a Like a commercial airplane going to the bathroom and it makes a really loud sucking noise when you flush the toilet. Yeah, that's a vacuum system. What else? Oh, come on. You guys are better than this. All the electrical, well, the batteries are part of electrical, but everything runs, things run off of the APU. The generator runs off the APU that runs the electrical system, right? So here's just some. So environmental control system runs off the pneumatic system. We use bleed air to run it. Pneumatic system, it could run on, it needs to get bleed air from somewhere, probably the APU or the engines, depending if it's in the ground or in the air. The engines of the APU, they need fuel to operate, so they're going to get fuel from the fuel system. The fuel system needs to have something to run the pump, so it can have electric pumps, or it might have pumps that are run off the engines of the APU, motive flow type pumps or mechanical pumps. So the electrical runs off the engines of the APU. The hydraulics run off the electrical of the engines. Hydraulic pumps can be driven directly by the engines or might come off the electrical system. Flight controls run off of the electrical system or off of the hydraulic system. So you can see these all, everything ties together. So as we go through this course, that's kind of the thing to think about is none of these systems can be studied in a vacuum. Okay, in the lab, I mentioned we're learning today about types of transport systems, and that's what your first lab is going to be. But then we're going to skip ahead to lab 5, which is the electrical system. So you learn how to power up the airplane so we can use that electrical system to power everything else that we're going to work with. And so it only makes sense that we got to go in the order it takes to power things up. We can't run the hydraulics without turning the electrical on first. Right? We can't run the fire detection protection system without having power to it first. So we'll kind of go through that. We can't run the flight controls until we know how to run the hydraulics. We can't run the hydraulics until we know how to run the electrical. So kind of the order is based on that. The other thing we're going to look at is aircraft design. So one of these things we look at is engine configurations. In modern transport aircraft, there are 5 common configurations of engines that you'll see out there. And they deal with the number of engines and location. There are two types of, or configurations where there are 2 engines. There's 2 types where there are 3 engines, and then we've got a 4 engine. So the first is a very common, probably the most common, is 2 wing mounted engines. And here you've got an example of a turbofan aircraft. The Qatar Airways airplane here has 2 turbofan engines mounted on the wings. I believe that's a 767, although I can't remember for sure. And then on the top right, we've got twin turboprop engines mounted on the wings. And that's a Q400-8 that was brought up earlier. Okay, that's a 50-passenger turboprop. Okay. The next type we have 2 tail-mounted engines. You'll see this is very common on regional aircraft, regional jets, and business jets. So this is a CRJ 700. And so you've got 2, in this case, turbofan engines mounted each side of the tail. They're on what are called pylons on each side of the tail. Okay. Our third is the first of what are called the tri-jets, or 3-engine configurations. So here you've got 2 engines mounted on the sides of the tail, 1 engine mounted on top, or in this case, the 3rd engine is actually mounted in the tail. There's what's called an S duct running down to it here. So you can have the engine actually up here. More common is there's an S duct where the engine is actually down here in the tail, and then you got an engine on each side. This is the 727, like what we've got out on the ramp here. It's a tri-jet, a 3-engine on the tail. The other tri-jet configuration is 3 engines where 2 of them are on the wings and 1 is on the tail. And so here is, you can see both these aircraft have a pair of engines mounted on the wings. The bottom left, the Swiss airplane, is an MD-11 where the whole engine is up in the tail itself. Okay, that's where I was talking about, where a 3rd engine can be mounted up in the tail. The top right, the ATA Air Italia plane, this is a S duct. This is an L1011. It's an older plane. You don't see very many. But this has an S duct with the third engine in the tail itself, with the air being ducted kind of down an S curve to that engine that's down in the base of the tail rather than up higher. So different. These were competitors. One was, okay, to do the engine like the MD-11, the Swiss Air airplane, there's a lot of structural reinforcement to mount a heavy engine up that high. But the aerodynamics of the air entering it are a lot simpler. The S duct on the L1011 in the top right, the ATA airplane, that S duct takes a lot more aerodynamic kind of thing to make sure the engine's going to get proper airflow. But you don't have to beef up the structure of the tail as much to support an engine way up high there. But at the end of the day, they're doing the same thing. You got 3 engines, 2 on the wings, 1 on the tail. And then finally, our 5th configuration is a 4-engine, and any 4-engine aircraft out there, commercial, okay, we're not talking military here. Any 4-engine aircraft out there today is going to be 4 wing-mounted engines. So like the 747 we have here in the upper right, the Cargolux airplane. The bottom left here is an Airbus A340. The only kind of the third one you'll see kicking around is the Airbus A380 double-decker. Those are around too. But there are a few other kind of random engine configurations. Some of them are military. The B2 have the 8 potted engines. And then there was a Russian airliner at one point that had 4 engines where they were mounted on the tail. They were 2 on the left side of the tail, 2 on the right, kind of pods. But again, not a design you see nowadays. So the 5 common, just to review: 2 wing-mounted engines, 2 tail-mounted engines, 3 tail-mounted engines, 3 engines, 2 on the wings, 1 on the tail, and 4 engines mounted under the wings.